this tutorial, you create a blockchain with a module that lets you write to and read data from the blockchain. This module implements create and read functionalities for a blog-like application. The end user will be able to submit new blog posts and show a list of blog posts on the blockchain. The purpose of this tutorial is to guide you through the implementation of a complete feedback loop, submitting data and reading this data back from the blockchain. By completing this tutorial, you will learn about scaffolding a Cosmos SDK message, defining new types in protocol buffer files, implementing keeper methods to write data to the store, reading data from the store and return it as a result of a query using the blockchain's key to broadcasts, transactions, and query the blockchain. Note, all the functions in this chapter can be scaffolded with a single command, but instead you will learn how to add each functionality individually. This series of blog tutorials is based on a specific version of Ignite CLI, so to install Ignite CLI v0.2.0.0 use the following command. Create your blockchain. First, create a new blockchain. Open the terminal and navigate to a directory where you have permissions to create files. To create your Cosmos SDK blockchain, run this command. The blog directory is created with the default directory structure. High-level transaction review. So far, you have learned how to modify proto files to define a new API endpoint and modify a keeper query function to return static data back to the user. Of course, a keeper can do more than return a string of data. Its purpose is to manage access to the state of the blockchain. You can think of the state as being a collection of key value stores. Each module is responsible for its own store. Changes to the store are triggered by transactions that are signed and broadcasted by users. Each transaction contains Cosmos SDK messages, not to be confused with Proto message. When a transaction is processed, each message gets routed to its module. A module has message handlers that process messages. Processing a message can trigger changes in the state. create message types. A Cosmos SDK message contains information that can trigger changes in the state of a blockchain. To create a message type and its handler, use the message command. The message command accepts message name, create posts, and a list of fields, title and body as arguments. The message command has created and modified several files. As always, start with our proto file. Inside the protoblog.txt proto file, the MSG create post message has been created. Edit the file to add the line that defines the id for message MSG create post response. Review the message code. Review the Cosmos SDK message type with proto message. The MSG create post has 3 fields: creator, title, and body. Since the purpose of the MSG create post message is to create new posts in the store, the only thing the message needs to return is an id of a created post. The create post APC was already added to the message service. Next, look at the xblog handler Go file. Ignite.cli has added a case to the switch statement inside the new handler function. This switch statement is responsible for routing messages and calling specific keeper methods based on the type of the message. The case types MSG create post statement handles messages of type MSG create posts, calls the create post method, and returns back the response. Every module has a handler function like this to process messages and call keeper methods. Define messages logic. In the newly scaffolded xblog keeper MSG server create post Go file, you can see a placeholder implementation on the create post function. Right now it does nothing and returns an empty response. For your blockchain, you want the contents of the message, title and body to be written to the state as a new post. You need to do two things. Create a variable of type post with title and body from the message. Append this post to the store. Define post type and append post keeper method. Define the post type and the append post keeper method. When you define the post type in a proto file, Ignite.cli, with the help of Protic, takes care of generating the required Go files. Create the proto-blog post proto file and define the post message. contents of the post proto file are standard. The file defines a package name username blog that is used to identify messages. The go package equals github.com username blog x blog types. When new files are generated, the message post. Continue developing your blockchain. Define keeper methods. The next step is to define the append post keeper method. Create the xblog keeper post go file and start thinking about the logic of the function and what you want to call the prefixes. The file will be empty for now. To implement append post, you must first understand how the key store works. You can think of a store as a key value database where keys are lexicographically ordered. You can loop through keys and use get and set to retrieve and set values based on keys. To distinguish between different types of data that a module can keep in its store, you can use prefixes like product or post. To keep a list of posts in what is essentially a key value store, you need to keep track of the index of the posts you insert. Since both post values and post count, index, values are kept in the store, you can use different prefixes, post value and post count. Then, add these prefixes to the xblog types keys go file and the constant in a comment that describes the keys. Your blog is now updated to take these actions when a post message is sent to the append post function. Get the number of posts in the store, count, add a post by using the count as an id, increment the count, return the count. Write data to the store. Now, after the import section in the xblog keep a post go file, draft the append post function. You can add these comments to help you visualize what you do next. First, implement get post count. Now the get post count returns the correct number of posts in the store. Implement set post count. Now that you have implemented functions for getting the number of posts and setting the post count, at the top of the same xblog keep a post go file, implement the logic behind the append post function. By following these steps, you have implemented all of the code required to create new posts and store them on chain. Now, when a transaction that contains a message of type MSG create post is broadcast, the message is routed to your blog module. Xblog handler go calls k create post, which in turn calls append post. Append post gets the number of posts from the store, adds a post using the count as an id, increments the count, and returns the id. Create a post, try it out, start your chain. Now that you have added the functionality to create posts and broadcast them to our chain, you can add querying. Display posts. To display posts, scaffold or query. Two components are responsible for querying data: an APC inside service query in a proto file that defines data types and specifies the HTTP API endpoint, a keeper method that performs the querying from the key value store. An APC inside service query in a proto file that defines data types and specifies the HTTP API endpoint. A keeper method that performs the querying from the key value store. First, review the services and messages in Protoblock Query Proto. The posts RPC accepts an empty request and returns an object with two fields, title and body. Now you can make changes so it can return a list of posts. The list of posts can be long, so add pagination. When pagination is added, the request and response include a page number so you can request a particular page when you know what page has been returned. To define the types in proto files, make the following updates in add pagination to the post requests. Add pagination to the post response. To implement post-querying logic in the gRPC query PostGo file, delete the contents of that file and replace it with a gRPC to the module handler. In the xblog module Go file, add context to the imports, don't save the file yet. Update the register gRPC gateway routes function to register the query handler client. Now that you've modified the file with the 2 updates, now it's safe to save the file. Use the key to create a post. Now that you have implemented logic for creating and querying posts, you can interact with your blockchain using the command line. The blockchain binary is blogged. The transaction is output to the terminal. You are prompted to confirm the transaction. Congratulations, you built a chain binary and used the blogged binary key to create a blog post. Use the key to query posts. Conclusion. Congratulations, you have built a blog blockchain. You have successfully completed these steps. Write blog posts to your chain. Read from blog posts scaffold or Cosmos SDK message. Define new types and protocol buffer files. Write keeper methods to write data to the store. Register query handlers. Read data from the store and return it as a result. A query. Use the key to broadcast transactions.